given that y is equal to this, okay, wow, okay, so this is a curve that I don't know how it looks like anyway, but we don't really care, right? Find the rate of change of x, okay, so we're supposed to find the rate of change, so there's a dx dt, right? So that's what we are after, dx dt, at the instance when y is equal to 1, okay, so pretty typical, alright, the information given to us, we know what we want to find, when, at which point, okay? Given that, okay, y is changing at the rate of 0.4 per second, okay, at this instance. So again, typical rate of change question, they give you a rate, they ask you to find another rate. So let's write down all the information that we know first, okay? So first we know that dy dt is 0.4, okay, so that is what we know. What we want, okay, will be what we call dx dt, right? And of course, what we want versus what we have, we need to try to link them up together. So dx dt is in fact the dy dt times dx dy. Okay, so this is what I want, this is what I have, and this is therefore what you need, right? So I need this to help me form up this equation, and therefore I can find what I want. So this is kind of again the kind of idea that we're supposed to be very good at. Okay, so focus on this now. Dx dy. How am I going to find the dx dy? Well, we do have the relationship between x and y. So it turns out it should not be a problem, except that we don't really have the equation of x in terms of y. Instead, we always have it y in terms of x. Well, it turns out that this is a small issue, because dx dy is just the reciprocal of your dy dx. So if I can differentiate this, I'm not that worried about things. Probably that's what we should do now, right? Okay, so let's get it done. Dy dx first. So dy dx, well, my assumption is, you know, we can do this very fast and very effectively. So we're going to get 3e3x plus e to the power of minus x. 1, you get 0. Okay, so there you go. This is my dy dx. Okay, and if I flip this over, I'm going to get dx dy. So probably I can write down the equation that now, that my dx dt is actually 0.4 multiplied by 1 over 3 of these plus this. Okay, here we go. It looks kind of messy, but we know we're on the right track, because all I need to do now is to do the substitution, isn't it? Yes, okay. Put in whatever number of x that we want. Okay, that's cool. Except that now it says at the instance when y is equal to 1, not x, is y. So you cannot really put 1 inside here, because it says y equal to 1 is not x equal to 1. So we have a little bit more problem, right? Which is what I like to call it, just probably a detour. Alright, so it's not so direct, right? So just substitute in, we need to go and figure out what is the x value when y equal to 1. So let's do it this way, okay? So when y is equal to 1, it means that this entire thing is equal to 1, right? So let's write down 1 is equal to e 3x minus e of this plus 1. Okay, and not very hard to solve this, I think. We probably cancel away, and we left with e 3x equals to e to the power minus x. How are we going to solve things like that? Now, again, some students, when they see e, the first thing they see e of x or whatever, they think of ln. Okay, it's not wrong to say that, but if you ln it, you probably end up with something that looks kind of weird. But in fact, this is quite solvable by itself. What I mean is, if you take a look closely, this is just 1 over ex, right? And if you do a cross multiply, you're going to get e4x equals to 1. And well, this is probably the point or the time that you start to do your ln, really. Okay, so when you start to do a ln here, you get 4x equals to 0, because ln 1 is 0. So 4x equals to 0, and therefore x is equal to 0. Okay, so let me write it properly here. Okay, so x is equal to 0 when y is equal to 1. So that's exactly what it is trying to tell us. Okay, so now what I need to do is to put in x equal to 0 into this dx dt, isn't it? Okay, so put in the dx dt. So when y equals to 1, x equals to 0, then my dx dt will be equal to 0.4, and then 1 over 3. E to the power of 0 is 1. Okay, so this whole thing is just going to be 1. Okay, plus e to the power of 0 again is just 1. so it's just 1. So it's going to be 1/4 here. Alright, and 0.4 divided by 4, that gives you 0.1. Okay, so the answer will be 0.1 units per second. That's the dx dt that we are actually looking for.